Cox. Brian Cox. And this is the story of our truly amazing and vast universe. We believe that all matter and energy, including the Earth, the galaxies, and the contents of intergalactic space, is just truly amazing and vast. In fact, what we have just described is our truly wonderful universe. I, Brian, am truly honoured to be here with Brian to discuss the wonders of the universe in this vast open space. Brian here is one of the greatest physicists and astronomers that I know, and not boasting, but I'm quite a good one myself. Sure you are, Brian. Now, let's get down to business. The thing is, I'm the centre of the universe. And so am I, and I'll show you why. Here, I have a balloon, which is a lot like the universe in many ways. You see, when the balloon is deflated, all the dots are close together. When it gets bigger and bigger, the dots, or galaxies, become further and further apart from each other, and the dots that are further apart are getting apart quicker. See, the outside of the balloon simulates the universe, and as the outside of the balloon has no centre, neither does the universe. Or everywhere is a centre. Now you see here I have a diagram of the universe, except the top layer represents a 5% expansion. Now you can see that when I line the top layer up with the bottom layer, it looks like that particular star is the centre of the universe. And when we do it with another one, that becomes the centre of the universe. Most astronomers believe that the universe began in a big bang about 14 billion years ago. At that time, the entire universe was inside a bubble that was thousands of times smaller than a pinhead. It was hotter and denser than anything we can even start to imagine. Then it suddenly exploded. The universe that we know was born. Time, space and matter all began with the Big Bang. In a fraction of a second, the universe grew from smaller than a single atom to bigger than a galaxy. It kept on growing at a fantastic rate. It's still expanding today, and it's so vast that it's impossible to imagine. In fact, here we have a picture of the visible universe, and we believe that it's even bigger. It's just the light hasn't travelled far enough for us to see it. As the universe expanded and cooled, energy changed into particles of matter and antimatter. These two opposite types of particles largely destroyed each other, but some matter survived. More stable particles called protons and neutrons started to form when the universe was only 1 second old. Over the next 3 minutes, the temperature dropped below 1 billion degrees Celsius, extremely cold. It was now cool enough for the protons and neutrons to come together, forming hydrogen and helium nuclei. After 300,000 years, atomic nuclei could finally capture electrons to form atoms. The universe filled with clouds of hydrogen and helium gas. The Earth probably formed a little more than 4.5 billion years ago. Like the other planets, Earth is made of thousands of molecules that are floating around in space in a nebular cloud of dust that came from the leftovers of our sun forming. At first, just a few molecules clumped together, then the clumps began to crash into each other. And stick together to make bigger clumps. After a while, there were big crashes as pieces of metal and rock, hundreds of miles across, smashed into each other. Finally, they were big enough to be a planet. The sun's gravity caught the new planet Earth and pulled it into an orbit around the sun.
In addition to going around the sun, the Earth also spun around like a spinning top, or like my head, for example. It takes the Earth approximately 1 day or 24 hours to spin around once. That's what makes it look like that the sun rises in the east and sets in the west every day, and it's why we have day and night. So night is when we're on the side of the Earth that is away from the sun. Thank you, Brian. That's enough now. Now that is a very good replica of the Earth. Apart from the Earth spins a lot slower than that, and over 4.5 billion years, it still hasn't got dizzy.
That there is a very good example of gravity on the Earth. In fact, if it wasn't for gravity, we could be floating about in space.
And all of this wonderful stuff we've been talking about, well, it's all not just on our Earth, which is just one tiny planet orbiting our sun in our solar system, amongst hundreds of billions of stars in our galaxy, the Milky Way, which is just one galaxy amongst over 100 billion other galaxies, including like the galaxy of Andromeda. And just to think of how tiny and insignificant we are compared to our truly vast universe just blows my mind, because we are just one tiny speck amongst all the other specks of stars, and I really just find that truly amazing.